From ContainerDays Hamburg, this video is proudly presented by DAX IT.
My name is Sebastian. I'm from the University of Applied Sciences in northern Switzerland. For those of you who does not know where this is actually, you take Basel on the left, Zurich on the right, and it's mainly in the middle. And what we do over there, we do some kind of lectures, research, everything related to also cloud nativeness. And one question which came up was how we could, is there a possibility how to trace vulnerabilities not only in the cloud native world, which is kind of established, but also in the legacy world, because we all have our technical depths in the basement. So, when I was sliding through the slides yesterday afternoon after the beer, I was seeing that at the moment there is just a new vulnerability coming up. For those of you who are eager to program with Node.js, I don't think there is a CVE listing yet available. Used by 18 projects, the lib is called QEX. I'm not a Node.js, I'm not a JavaScript developer. Nevertheless, about 2.6 billion downloads over transitive packages at the moment. Yeah, and just because of a phishing attack, as far as I know, just become vulnerable. So this is just coming in as a motivation. And now kind of little interaction time. How many software dependencies, just think for yourself, how many software dependencies do you have in your own application? So just as a side quest, if you are having a Spring, a Quarkus reactor, it's about, with transitive dependencies, it's about 200 till 300 dependencies. When you take the legacy parts into account, so that means you are not only having your own container, but you have also any kind of load balancer, any kind of additional service. How many dependencies do you have over there? Yeah? And the last question is, which dependencies actually are on the execution path of your request? So just think of your overall application. We all know this famous Log4Shell vulnerability a couple of years ago. So you have any kind of request, it's coming into your load balancer, your application handles it, and then it goes to your legacy part and goes back to your cloud native part and so on. The answer to all of these three questions actually gives you the answer of where is your own application vulnerable or where it is not. So, we are just starting with a little scheme. We got on the right side, we got an arrow. A request comes into any kind of legacy server. It's going to be handled as a legacy server. Let's say it's a load balancer, something front-end, Node.js front-end, whatever. And then it's going to be forwarded to your new world, to your Kubernetes cluster, handled by your pod, and then forwarded to another service, and so on and so forth. So tracing over here in your Kubernetes cluster is easy. Yeah, we got a fabulous talk, I think, yesterday in the morning about OpenTelemetry with this annotation-based. You got your sidecars, you got the service meshes, and you have your Jaeger, Zipkin, whatever instances, and you can easily trace them. Well, tracing on your legacy part on the other side is quite hard because it's not there. You have, in most cases, some kind of old monolith, maybe JE, web application server stuff, call it your WebSphere, whatever. And this stuff can't be enriched very easily with any kind of traces. Yeah? So, exactly. The second aspect we have to take into account is the aspect of SBOMs. And SBOMs, on your pods, it's quite easy as well. You got your CI/CD pipeline, you got your tool set over there. You're going to generate your OCI image. You're going to auto-generate your SBOMs with various tools, and you can just reflect them. You can just scan them, whatever. Dependency management on your legacy part is quite problematic as well. But what you need to know is you need to establish knowledge about your entire system to gain awareness about any kind of vulnerabilities. So we try to tackle this challenge with 2 steps. The first step is we are going to generate holistic SBOMs. So we all know this famous XKCD comic, I guess. And SBOMs in the cloud native way is quite easy. You have your OCI image. You're going to kick all unnecessary packages out of your OCI image, and you have a very clean image. And you can scan it, and you can just lie to your, I don't know, Artifactory, Harbor, wherever you like. So. This OCI image includes the application, the OS layer, and it includes all packages, and the SBOM is going to cover everything over there. On your legacy part, we actually have to generate 2 SBOMs. So the first one is your application. Let's say we got your Java JE application, then you're going to take your Maven, for example, and you generate your SBOMs. But we also have to generate an SBOM of your basement, of your traditional infrastructure, of your OS, including your application server. Esra is going to tell you in a couple of minutes how we are going to do this. But actually what we are going is, this is the distinguishing between dev and ops, yeah? And the ops guys need to have any kind of SBOM as well, and we can generate it quite statically, yeah? But it's working. So that's the first step. We need to have an entire SBOM generation. And the second step we are going to do is we are going to generate traces. Well, in the Kubernetes, as I said, it's quite easy. Yeah? We have any kind of, either we are going to instrument our application manually, or we are going to have any kind of auto-instrumentation in place, or we are going to work with any kind of sidecar. But yeah, it's straightforward. So we are going to have our traces, and we are going to push our traces to any kind of collector. In our example, it's a Jaeger instance. In the monolith, it's a little bit more complicated, but we found a way how to do it. Actually, we used eBPF to the rescue. What we are going to do is, there was an external external workload component existing in Cilium, which we are going to use to enrich the network connections with span information. Yeah? So our assumption was maybe we get our ops guys to install any kind of additional in user space running tool for once, and this would enable us to have any kind of holistic view related to the network connections. So Esra will show you now the application, how it's going to look like.
So good morning from my side. This is how our approach looks like. Our approach consists out of two components. We have on one side the Cilium agent, and on the other hand the Cilium server. The Cilium agent is distributed as a daemon set on the Kubernetes cluster, or is started as a container on a normal host. Spanned over the, as Sebastian mentioned, is the Cilium network, which we access to receive network events, so we can process them, and we can check on Kubernetes cluster if we have already an SBOM for the corresponding image, or if we are on a host, we scan the file system for dependencies. Of course, this takes, depending on the host, some time, but if we have done this once, the normal host isn't changed that much like we have changes on a Kubernetes cluster, probably. So if we receive such an event, we send that via NAT to our server, where we generate, based on the network events, the traces which are sent to Jaeger. The SBOMs itself are sent to Harbor, where we can access them as an OCI image. Oh, yeah, I have to press. So how does this look like in Jaeger now? We have, on one hand, we have the image. We have there the digest, so because the tag isn't enough to specify the image, as we see here, we have a latest image. And the most important part here, we have the SBOM URL. So what can we do with this information? We have here the trace, and we have the corresponding SBOM's URL along with the trace. So we can use an existing tool, like in our case we used Scribe to scan the SBOMs. So we can generate a report based on a trace ID, what the vulnerabilities are on this trace. And of course, we have added some metrics. So in our test scenario, we had total CVEs, 492 CVEs. And we have had 191 unique CVEs, which means probably there are some CVEs which are in multiple images and some are only in one image. And so we have there a unique number of vulnerabilities. And now more interesting is how are these vulnerabilities distributed? How many critical vulnerabilities do we have? How many negligible vulnerabilities do we have? And this can we see in this diagram. The same as before, we have the distribution for the Unix CV. So we see there a little bit less critical incident or CVs, and some more medium. But this is always only statistics, so we need to know where these vulnerabilities are. Of course, there we have another metric, so we can list them here. We see which CVs occurs how often, and of course we can see where on our cluster, or if we are on an external workload, where are these CVs, so that we can patch them. This gives us a holistic view over the whole trace, where the CVs are, and where we have to patch them. Yeah. And that's it, probably nearly from my side. I give back to Sebastian.
Yeah. So overall, this is a lightning talk. We are just at the end. Just to give you a brief overview what we are actually doing. So we try to combine vulnerability management together with any kind of request management. So on the vulnerability management side, we are using well-established tools like Scribe in our example, which gives us also the possibility to scan entire file systems, not only containers, which we make use of. We are going to store the SBOM with an SBOM management, store it like any other SBOM and any kind of existing appliance like Harbor in our example. And on the other hand, we are using well-established methods from the request management. So of course we are using tracing. This is a no-brainer for most of us. And on the legacy part, we're going to hook with Cilium directly on the operating system level. We are not going to alter the application server. And yeah, on this level, we are going to make use of Cilium. So if you are interested, it's a proof of concept. It was part of the master thesis. Check it out, give us feedback, and hopefully you are going to enjoy the rest of the day. Thank you very much.
How do you put the SBOM info in the tracing tag?
Yeah, we received the network event from our agent, and then there we generate the whole trace on the server side, so we can add them as a tag to the trace, and then push them. And
why don't you use Trivy?
I guess we used it for the operating part also, did we?
We evaluated it, but this was just a tool.
It was just another tool.
It's not.
What worked best, we used. Yeah, not
Thank
real
you.
reason.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.